Now for problem D, it's asking us, given some numbers from 1 to n, and each of them exists exactly twice. We have to guess how it looks like using only at most 3n queries. Okay, here, almost 3n queries. At each query, we are telling him what's the mad value for these indexes. Okay, so what is mad? Mad is just telling you what is the maximum element that occurred twice. For example, 1 to 1. Maximum element occurred twice is 1. 2, 2, 3, 3. There are 2 exist twice. 2 and 3, right? What's the maximum? 3. So it will tell us 3. 1, 2, 3, 4. Nothing occurred, right? So the algo is 0. So when there is nothing occurred twice, we are saying 0. Okay. You may say, okay, but we should know what is the constraints, because maybe we will say big indexes, give it to him and ask him about it. So we may have a look at n. So n is 300, which allows for n square and similar operations. So or similar complexity. So we can do n square. It's okay. So now, the answer here is, first thing, by intuition, it's clear that we can just, okay, let's ask him, we don't know the array, right? What if we said the first 2 elements, the first 3 elements, the first 4 elements, or anything like that, until it's give us a non-zero answer, for example, 1 or 3 or anything like that. When it give us this, what does this mean? It means that at the ith place we are at, there is an answer that, look, everything before me is 0, 0. This one was 0. This one was 0. But now I found a non-zero item. Let's say 3, for example. So if this happened, then 3, then this one is of course 3, and there must be a 3 occurred before here. And then I'll exclude 3 from my indexes that I'll ask about them. Okay. Why? Because if I, for example, in the next one was just 2, so it will give me 3 again if I didn't remove this. But this will assure that 3 will not appear again. But don't forget that at this time, we already know, let's consider that our answer is array answer. We don't know what exists here, what exists here, what exists here, but we are sure that there's a 3 here. Now, we are still holding all of these indexes, but we just remove this index because we know it's the answer. So now we will ask the mad query again. Here, it will give us 2. And this means that this one is 2, and it occurred again here. It occurred again, yeah, here. There is 2 here. There must be 2. But we can't know now where is 2 here. Okay? Same thing for the rest. Consider the last one was 1. So how many queries we've done so far? We are looping through all of this array. The array is containing exactly twice from all of the elements from 1 to n. So its length is 2n. So we've done 2n queries. Okay. Now we are left only with n query, right? 3n minus 2 minus 2n. Anyway, so the idea here is, don't forget that you know the answer at some specific indexes, right? So using these indexes, for example, here, I know that 4, I know it's the answer, index 4, which is this. Yeah, I'm using one-based indexing. So here 4, here 5, here 6. I know the answers at these indexes. So what will happen if I made a query now, mad query, at this place? I'll add this place, and I'll add all of these places that I know their values. What will happen if this one was, let's say, 1? So it's similar to saying 1, 3, 2, 1. So the result will be 1, which is, it will just literally tell me this question mark is what element. It will give me the first occurrence of 1. Then I'll ask the same question with all of the indexes, which contains all of the numbers from 1 to n. If I ask it any question mark, the question mark is just the place where I don't know its value, but I know its index. So I'll just use its index, add it with the indexes that I know their values, which is from 1 to n. And this is for sure will give me the value at this question mark. How many times I'll do that? I'll just do this query whenever I see a question mark, which is a place that I don't know its value. So I'll do exactly n queries. In each of these queries, I'm adding the index of this question mark plus the indexes that I know their value, their answers, and it will always return the answer at this specific index. And then I'll be done with 3n queries, which will give me the answer. I'll just print it. Let's have a look at the code. So in the code, by the way, if you're not familiar with what's flush, flush is just something in Python, for example, we say comma flush equal true, literally, when we print anything. That's it. This is for interactive problems. Anyway, so here I made an array answer, which starts with 0. 0 is similar to the question mark we made. Times to n, just its size, loop through everything. This is the first process, which is the 2n queries. I'm just holding all indexes. All indexes, by the way, is just like the indexes that I know now their answer, which is the second occurrence of every number from 1 to n. And current is just the query that I do. So whenever I see any item, I'm adding index not I, because the interactor understand one-based indexing, not 0. So I'm just adding 1 to it. Anyway, so I'm adding everything I see, and I take its result using this query function, which is just making a query. And then if the query is non-zero, then I know the answer at answer I, which is the result coming from it. I'll pop it because, as I said, I don't want to ask it again, because if it's something big, then it will appear again. Even the next one was 2, for example, and I want 2, not 3, right? So, and then I'll add its index. Why this? This is just the we will be using in the next part, which is all indexes, like the indexes of 1 to n. Anyway, and then I'll do the other thing. If there's 0, which is similar to question mark in my explanation, and then I'll take its result from the query, and yeah, everything as I explained. Implementation is very simple for this problem. Then I'm just printing everything. Literally, that's it. I hope you enjoyed the tutorial. It's my first time to do that. And please comment below and tell me anything that will help me improve the coming editorials. Thanks.